Hey guys. Okay, we're back. All right, what we're going to try to do today is we're going to kind of start on the next chapter. All right, so the next chapter is going to be about a bunch of different kinds of integration techniques. Okay, I've ordered a whiteboard from Amazon, but as you can imagine, shipping's a little backed up right now, so it's going to be a week or so before I can get that. So what we're going to try is I'm going to try to kind of put a PowerPoint on the screen that's kind of got my work on it and kind of talk you through it. Okay, so what's going to happen is when I share this PowerPoint, I'm going to kind of go to the top of the screen and the PowerPoint will be what you're looking at and I'll talk you through it. So let's see if we can get this to work. Okay, here we go. Now let's see if we can find it. All right, there it is. Okay, now let's see if it'll come up. Yeah. Okay, now here's what I want to talk to you about. The very first chapter that we're going to that's new is going to basically be chapter 8. We're going to kind of skip over chapter 7. We'll talk about that later. I'll double check and make sure it's the right chapter number, but we're going to kind of move to this very first part. All right, let me look at my book and just see what section this is. Yeah, this is 8.1. Now, 8.1 isn't anything new, so I'm not going to take long to talk about it. It's just a review of all the different kinds of integration techniques you're supposed to already know how to do. Because when you were doing like volume and area, you kept just getting a bunch of power rules, and so sometimes you've forgotten the old ones. So these are just some that I kind of created. Some are in the book, some aren't, just to kind of remind you of some things. All right, let me get a little pointer for a second. Okay. Notice that number 1, number 2, number 3, and number 4 look a lot alike, but they're not remotely alike. So remember, just like we talked about in class, the first thing you're going to do is try to figure out, what do you think of first? And so you have that running list of integration techniques in your head. But remember, I need you to go from the first thing you learned down to the last thing you learned, because they're going to get more complicated, and we don't want to complicate a simple problem. All right, so when I see all of these, 1, 2, 3, and 4, I notice that I've got a fraction. So what's the first thing that you think of when you have a fraction? All right, should be natural log. So look and see which one of these you think might be natural log. So remember, for natural log, you have to have the derivative of the bottom on the top. So what's the derivative of that x squared plus 9 is going to be 2x. So see, I can't turn a 4 into a 2x or a 4x squared into a 2x or that one, but I can do number 2. I could pull that 4 out, like over here, and then multiply by 2 on the top and 1/2 out here, and then have natural log. Okay, so this one's worked in your book. Okay, if it's not natural log, remember, what should you think of next? Well, I notice on this one, I've got a power. Okay, so remember, if it's power rule, the power needs to be in the top. So I pulled it to the top, so that made it a -5. All right, and I still have this 4x, but I pulled the 4 out, and that left the x. And so you need the derivative of the inside, which is 2x. So you need to multiply by 2 here, and then a 1/2 out there, and you would just have power rule. Now, this one, notice the power on the top's the same as the power on the bottom. Remember, when it's the same on the top and the bottom, or when the top has a higher power, you need to do long division first. And we talked about how to do that in class, so hopefully you have notes. So this is what you ended up with if you had long division. So you can already integrate the 4, and then this part right here is going to be like number 1. And number 1's arctan. Remember, arctan is something squared plus something squared. Remember, your a is your number, so your a would be 3. Your u is your variable, so u would be x. And you would need the derivative of that on the top, which is a 1. So when you pull that 4 out, you're good to go. And this one's worked in your book, so you can see it worked out. And then this second half right here would be another arctan. Okay? Now, don't forget common little things we learned at the very beginning, like on this one, the derivative of the inside would be 4x, and you don't have an x, so you can't do power rule, but you could just multiply 2x squared plus 4 times itself 3 times, and then do everything term by term. All right, on this one, sometimes you have to rewrite it algebraically. You know, another way would be, you know, dividing by t to the fourth is the same thing as multiplying by 1 over t to the fourth. So I've got e to a power, so I would need the derivative of the power. And when you do the derivative of that power, you're going to get this thing over here. You just need a negative. That's easy to fix. So this is just e to a power. So kind of go back and look over. I'm going to put some problems on Moodle from 8.1, but there shouldn't be really anything new. It's just review. All right. Now for the new stuff, we're going to talk about something called integration by parts. All right. But in order to do that, the first thing I want to kind of do real quick is show you where the formula comes from. Now, remember in Cal 1, you had derivative rule for a product. So remember what the derivative of a product was. It was the first times the derivative of the second, and then plus the second times the derivative of the first. Okay, so this top line is just what you learn in Cal 1. Well, what we're going to do is we're going to integrate both sides. So I just put an integration in front of this left side and an integration in front of this right side. Now, what happens when you integrate a derivative? Remember, they're inverse operations, so they undo each other. So that's why I just get UV. And then when you have two different things, you're going to integrate the first one and integrate the second one. I just separated them. Remember differentials. So the derivative of v with dx is just dv, the differential of v. And the derivative of u with dx, or the differential of u. Okay, so that's all I did there. Then to get this boxed formula, all I did was solve for this one. Okay, so basically, I just left this one and moved this one to the other side. So uv, so I subtracted this one from both sides. Now, this boxed formula is the one that you have to memorize. Now, when you take your test, you'll have your book and your notes, but you know, in Cal 3 you won't. So you do need to memorize this little formula. So the integration of u dv is u times v minus the integration of v du. So that's called the integration of parts formula. Now, how do you use that? All right, well, let me show you. Okay, here we go. There's that formula. I just wrote it out again. Okay, so the integration of u dv is uv minus the integration of v du. So what happens is, when they give you a problem, you're going to let part of your integral be u, and you're going to let the other part that's left over be dv. Okay, now on page 523 in your books, there's kind of some guidelines, but these are basically, there's not, again, these are guidelines, you know, Pirates of the Caribbean, not rules. So nothing set in stone. You get to pick which part you want to be u and which part you want to be dv. So generally speaking, you want u to be something you know how to take the derivative of, and dv is something that you know how to integrate. And you would like to try to go to simpler things. Now, sometimes it doesn't matter, and sometimes it does. Let me kind of show you what I mean. On example 1, if you want to integrate x e to the x. Now, the first thing when I see this, I think, ooh, maybe it's just e to a power. But the derivative of my power would be 1. And I have an x I can't get rid of. Okay? So I'm kind of stuck. And integration by parts works really well when you have a product. See, it's a product, u times dv. So when you have a product of two different kinds, like an algebraic and a trig, or a e and a trig, or an e and an algebra. So I've got e and algebra. So that's why I would think to do integration by parts. I've got a product of two different kinds. Now, this is arbitrary. I decided to let u be the x. So then the rest has to be my dv. Okay, now every time you're going to have 4 pieces before it's finished. You're going to have a u, a du, a dv, and a v. So whatever you pick for u, you take the derivative of that. So the derivative of x is 1. Now, why is that dx there? Because we're doing the differential of u. So remember, the differential is the derivative with dx stuck next to it. Okay? Now, dv is what's left over. Now, how do you get from dv to v? Well, you're going to have to integrate. So when you integrate e to the x dx, you just get e to the x. So there's your 4 pieces. There's your u, there's your du, There's your dv, and there's your v. Okay, so this is the integration of u dv equals, and I just wrote the formula down, u times v minus the integration of v times du. And then I just plug in from over here. So remember my u was x, so for u I put my x down. My v, remember we found our v, we integrated and found it was e to the x, so I put e to the x, so u times v minus the integration. Then my v, remember my v is still e to the x, and then I put my du. Now du is 1 times dx, but 1 times dx is just dx. Now this part is already integrated, so to speak. So it just stays x e to the x, but I've got to integrate this. But what's the integration of e to the x is just e to the x. And then remember at the end, don't forget your plus c because it's an indefinite integral. All right, so let's go look at another one. Okay, here comes another one. All right, again, see I've got an algebraic thing and then I've got a natural log. Okay, now I know how to take the derivative of natural log, but I don't know how to integrate natural log. So I couldn't let dv be natural log because I wouldn't know how to integrate an ln. I know how to take the derivative of ln. I know how to get ln for the answer on the integration, but I don't know how to integrate when it just says ln. Okay, and generally speaking, you want the integrations to be simple and the u's to be simple. Okay, so I'll let u be what I could take the derivative of. So my u is the natural log of x. Then dv is what's left. So it's the x squared and the dx. So there's my dv. Now, how do you get the other two pieces? Well, to go from u to du, remember you take the derivative. So what's the derivative of natural log of something? Remember what follows ln goes on the bottom and the derivative of that goes on top. And the derivative of x is 1. And because it's the differential of u, that dx has to be there. Okay, so the derivative of natural log of x is 1 over x, then I've got my dx. Okay, making sense, I hope? All right, now how do you go from dv to v? Remember, you integrate. So when you integrate x squared, that's just power rules, so I get x cubed over 3. All right, so here we go to our formula. The integration of u times dv is uv minus the integration of v du. So my u, remember, was the natural log of x, so in place of u, I put ln of x. My v, remember when I integrated over here, was x cubed over 3. So in place of v, I put x cubed over 3. And then minus, and then my integration. Now, what was my v? Remember, my v was x cubed over 3, so I put it there, and then my du. And du was 1 over x dx. See, 1 over x dx. So this part's kind of what you think of as already done. So that's natural log of x times that, but I've got to integrate this. Well, let's simplify it first. I don't need that 3 on the bottom, so I can pull the 1/3 out. That's going to leave me x cubed. And then I've got an x down here, so that simplifies to x squared. So all I did was just pull the 1/3 out and then simplify x cubed times 1 over x to x squared. All right, then I've just got power rule. When you integrate x squared, you get x cubed over 3. All I did here was just change the order so that I wouldn't accidentally multiply x times x cubed over 3. You don't have to change the order. All right, and then of course 3 times 3 is 9, so that's where I get this answer on the bottom. Okay, all right, let's try one more. Okay, let's look at this last one. All right, now here's example 3. All right, same kind of thing. Remember, part of your integrand is going to be a u and part's going to be a dv. Now on this one, I know how to take the derivative of this one, and I know how to integrate that one. So instead of letting u be x, I could have worked it letting u be sine 2x. I know how to integrate x, so I could have switched these two things, okay? But taking the derivative of x makes it simpler. And usually you want to take the derivative of something and make it simpler, okay? All right, so here we go. There's our formula. The integration of u dv is uv minus the integration of v du. Remember, I let u be x, so dv's got to be all the rest of that. All right, so there's my dv, sine of 2x dx. Now, how do you get from u to the differential of u? Remember, you do the derivative with dx. So the derivative of x is 1 times dx. How do you get from dv to v? You have to integrate. Well, you're integrating the sine of an angle. Now, remember, when you're integrating the sine of an angle, you have to have the derivative of the angle. So I'm missing the derivative of that angle, which is 2. So I'm multiplied by 2 here, so I have to have 1/2 out there. So my v is my 1/2. Now, what happens when you integrate sine of an angle? Remember, you get negative cosine of that same angle. So my v is a negative 1/2 the cosine of 2x. Okay? So let's go back and plug in. What's my u? My u is x, so in place of u, I have an x. My v, remember, is a negative 1/2 cosine of 2x, so in place of that v, I put negative 1/2 cosine of 2x, and then minus, so there's my minus. My v, so there's my v again, that negative 1/2 cosine of 2x, and then my du is just that dx. Okay, so does everybody see kind of what we got here? Okay, so then all I did was bring that down. I pulled the negative out. Now, what's a minus a negative? See, there's that minus that negative. I pulled that negative 1/2 out, and there's what's left. So that just comes down. It's already worked. Now, minus the negative's a plus. There's my 1/2, and I've got cosine of an angle. So I'm integrating cosine of an angle. So remember, when you integrate cosine of an angle, you need the derivative of the angle. So what's the derivative of your angle 2x? Okay, that's right, it's a 2. So if you multiply by 2 here, that's the derivative of your angle, and you have to balance that by multiplying out here by 1/2. Well, then 1/2 times 1/2 is where I got the 1/4. Okay, so what happens when you integrate cosine of an angle? What is cosine the derivative of? Remember, sine. So when you integrate cosine, you get sine back. And then remember, at the end, always put that plus c, because these are indefinite integrals. Okay, so I'm going to you some problems out of your book to work on integration by parts. Okay, now if you have trouble, if you're getting them right, life is great. If you're not getting them right, you can snap me pictures and send me your work, and I can find your mistake and send you some feedback. Or you can come and meet me on a Zoom meeting if you need some help. Okay, if you can't meet at the regular Zoom meeting time, send me an email and we'll figure out a way to do it one-on-one. Okay, this is not hard, it's really easy. Now, you can do integration by parts more than once in the same problem. Okay, but we're not going to do that yet. We're going to get really good at doing it once. And then I'll show you a shortcut a lot of times when you have to do it more than once. But you can't always use the shortcut. So we've got to get good at doing it this way first. Okay, so you check Moodle for your homework on integration by parts, but don't even worry about that till after your test on Thursday. You can do that kind of over the weekend if you want to. Okay, and I'll put another video up before the weekend about the shortcut. Maybe, maybe not. We'll see. You just keep kind of checking. So I'll give you some homework to do before Tuesday of next week. But don't even start that until after your test on Thursday. All right, thanks. Okay, we're going to stop this, and then we're going to stop the video. Okay.